shell command inside the pig script. We already gone through that one. But the only caveat, wherever you run this file system command, there is not guarantee that pig would execute in that order. Suppose you define the statement like a equal to load some sample file, okay, like, and then you filter a by some values which are greater than some values, which are some greater than some values, okay, like that. And then after that you added like file system command. But whenever you are executing the pig, okay, like so, don't expect that okay this file system command okay would run after executing event B. Typically, it will not run like that. So instead, first it will finish all the file system commands, and then later on, it will run, execute, and your pip statements. Okay, like so. That is one caveat. Um, Remember only one thing: your pig Latin script, entire the pig Latin script would be converted into a Java mapped program. So any command that you list down using a file system or shell command inside the pig script, they will be executed first, and then after that, like your Java mapped this program would be run. Okay, so that's the only the thing. Just remember that. Okay, I got my cluster here. Let me try to log in. Okay, so I think sample.txt already I shown you like how to read from this sample.txt file and how to read each column by column. So like we already covered that. And then next one is bag data. I shown you how to run, how to make a group statement. So if you want to group all these tuples using field 1 or field 2 or field 3, how to do that one. We already covered that one, that part as well. And the next one, um, uh, I want to give a try with the filter. Okay, like so. Filter, and then I don't think we covered the filter. The next one is for each. Okay, like I would like to go through that for each. I think as Murthy requested in the last class. I'm not sure Murthy is joined or not. Okay, like that. That's fine. Um, okay. For each and filter condition, and then I will explain about differences between dump and store. Okay, like so. Dump and store, and then I will try to explain about evolution functions as well. Okay, like some of the evolution functions. Okay. Yeah, without wasting much time. Okay, like let's go through that. Pig minus x local, because we are using the local here. Um, Pig supports multiple modes of execution, pig minus x page, okay, like pig minus x local, pig minus x mr, or you could just enter using pig as well. So all these options are available in the pig. For us, since we would like to read the files from the local file system, so we are using the pig minus x local. Okay. Again, I'm back to load, okay, like bag data dot text, okay, like using its storage. Uh, let's try to put only in code. I think even double quotes also may work. Um, Using quick storage, hash, and then you could say f1 is integer, f2 is also integer, f3 is also integer. So I'm trying to read from this text file, which has three fields here: field 1, field 2, field 3. Field 1 is of numeric digit, so I'm defined field 1 as integer here. and F2 is also a similar type of values that F2 has. So I define the F2 as integer. And here, the column name and its data type both are separated by the colon. Okay. Um, we know that we could run describe A. Okay, like it will give you exactly the schema definition of the alias A or schema A. And the next one is illustrate. You could use that, and explain A will give you the logical, physical, and MR plan. Okay, like of how this variable will be, or how this alias or schema would be going to execute it. And the third one would be um, illustrate A. So it will take one sample row, okay, like, and then using that values, it will try to explain, okay, clearly, like what is happening, okay, like in the step by step of, okay, like whether it can be map reduce or whether it can doing any filtering, whether it could doing any group by or any operation that you do using the pick script, okay, like so this illustrate will give you that, okay, like with corresponding example raw data. Here the describe A, and we would like to have A equal to, okay, like filter A by F1. I want to have the values F1 equal to 4. Okay, so dump B. So from the back data, I want to have all the rows which has, okay, like field 1 value as 4. So there are 4 rows exist. So I got all the 4 rows. This is the A statement and this is my B statement. Okay, and out of this, okay, like again, if you want to do that, if you want to do further, okay, like uh, uh, any filter or even for each, also we could do that one. Let's go, let's try to see C equal to, so, and then we use the dump C here in the next statement. So pig always, whenever you try to, for example, okay, like so A, B, C, D, right? So all the statements. So you do one thing. You try to copy your big script, okay, like which has all the statements. Okay, like statement A, B, C, and then like a dump statement, whatever it is. Okay, like so. What we could do is, okay, like so, I'm just it from here. Okay, like, and then I put like back data demo dot p, and here try to copy all your statements into a file. Extension, it need not be big, okay, right, but you can do any text file would work in that manner. Okay, like so pig minus x local, and I think bad data demo. Okay, like so this is how you would execute um, sequence of the pig statements, putting in a script, and then you could execute it. It will run step by step by step. 1, 2, 3, like that. And then you could see the 36, 9, 0, 36 at the end of the value. Since I given the dump, um, the value would be, okay, like displayed on the screen. But instead of dump, there is other way also, like we could use, okay, like so store. Okay, this time, anyway, we know that dump, and you could prefix it with hyphen hyphen, okay, indicate that there is a comment. Also, pig allows you to define uh, comments like this also. C language or Java language comments, okay, like you could use that one too, multi-liner. And the next one, store C into, um, I could say bad results, okay, and using big storage. It doesn't matter really, like so here I don't think, because we are expecting only one column, so it doesn't matter. I think this should work. So instead of dump, I'm using the store statement here. And then let's try to run that. Okay. So now you will not see the results here on the screen because we are not using the dump statement. So instead of dump, we use the store statement, and store will simply store the data into whatever the path that you have given. And pig always writes into a directory. Pig will not write into a file. Okay, remember that always. Because pig will generate a MapReduce program, and inside the MapReduce program, okay, like so, you don't know how many mappers that it will get invoked, and each mapper would write its own corresponding file. Okay, like so, it's not, even though you try to invoke with one mapper, but there is no way that like you could define your output file name while writing from pig. Okay, so here in this, you could see that there is a directory created as bad results. One more time. Okay, like let's see the script. Observe the last line. So here store C into bag results. So the path, whatever the path that you are going to give in store statement, it can be a, it should be a directory. Okay. And here the bag results is a local directory because I started with the pig minus x local. If I started with just pig minus x mr, then this directory would have created in HDFS. Okay. Uh, let's see that inside bag results and observe the file name. There is a path M00 like that. So this is the output file generated by the MapReduce program. In fact, mapper program. Okay. Any output from the mapper will have the part M like that, and 0 is the first mapper, and then it will have part M0001, part M002, part M003 like that. If there are four mappers, then you will see that part M00, part M0001, part M002, part M003 like that. Okay, and if there is any reducer, reducer got invoked by the by the operations, whatever the operators or whatever the operations that you define in the fixed script, then you could see the file names as path R000, path R0001. So M stands for mapper, R stands for reducer. And underscore success, okay, like this is a 0 byte file which will get generated. Typically, um, uh, this file indicates that the job has completed writing the file or files. So suppose you know that some particular script is writing into this directory like bad results, and then inside that you would be always looking for this file. So whenever this file exists, then you could simply copy the data from the directory, and if this file is not being generated, that means the script or the job is still writing the data into the directory. Okay, like how I know that? Okay, like the process which is writing into that directory has completed in writing by seeing this empty file. So at the end of the copying or at the end of the file's generation, the system would write this success file. Okay, like so if this success file got exist, then you could safely copy the data from that directory. Okay. So you could see that cat part M000, and then here you could see the result 369036. So whenever you use the dump statement, okay, you will see the results on the screen, and instead of dump, if you use the store, okay, like the output would be stored inside the directory. Okay, um, that is the high level difference between dump and store. There is one more, okay, like difference between dump and store. Let me do that. Yeah, you could execute using local as well. I got a statement, And let's go to the B statement, dump B. So here, if you observe, I added two dump statements inside the script. Okay. So this is my sequence. First, I define the A, and then I define the B. Then I started the dump, and the next one I define C, and then dump C. So I introduced dump B, okay, like in between the B and C statements. So in this big script, totally there are two dump statements. Okay. Uh, Whenever pig sees this dump or store, then it will start the execution from that statement. Okay. So I added dump B and dump C on that. Okay. So we run the script, and if you closely observe, okay, like starting from the fixed statement, okay. So this is where I have given, right? Ping assets local backdata given. If you closely observe, it started with it started with the job. So this is one job tag, okay. So it started with one job, and then it will continue further. There will be a second job. You could see that one. Job local 1010456345 and 002. And the earlier one is ending with 001 here. So there are two jobs which have been defined for two dump statements. So what would happen is whenever it sees multiple dump statements, then multiple DAGs would be generated. A DAG is nothing but it's called directed acyclic graph. So it's just a sequence of your MapReduce jobs, or sequence of MapReduce um, operations or MapReduce sequences. So how many jobs got, uh, and each one would call like one MapReduce job here, and in this DAG represents, there are two jobs which would be called. And because there are two dump statements are exist in the fixed grid. So each dump statement, okay, try to evaluate, okay, like try to convert into its corresponding data. Okay, so that's for the behavior of the dump. But instead, if I go one dump and one store, still you could see the same behavior. Uh, Tag results, let me put as one, okay, because the results is already exist, right? So this time I'm trying with one dump and one store. Let's try to run. Okay. Even this time, you could see that there are two DAGs which have been defined. One is like 001 here, and another one is 002. So in case of dump and dump or dump and store, okay, like it generated two different DAGs, and obviously like there are two different jobs which we already have. But whereas if you have two stores, Oh, maybe I will have left that one. Okay, I will try to comment this. So instead of dump, I made it as a store statement. So there are store B and store C. Normally, whenever you have a store, people try to define into where you want to store that. So that um, is output. Okay. Now, if you try to run the same, so I just changed from dump statements to the store statement. Oh, there is one error. So because results one is already exist here. Line number 8. Oh, I missed a single quote. If you observe that, even though I give two store statements in a fixed array, but at the end it was generated only one job, one job bag or one job. So in case of dumps, okay, like it was generated like separate jobs, but whereas in case of store, we try to optimize how many number of jobs that it will get converted, and if it is using the same variable, it will try to run only one job. Okay, that is the other difference between dump and store. Uh, Multiple dump statements cause okay, like different tags okay, like to generate and execute okay, like at the time of execution of the jobs. But whereas multiple stores okay, like it will try to evaluate and convert into a single DAG while executing the jobs. So there is a difference between dump and store. Even you have a combinations of dump and store, but still it would be have the same way as all the dumps. So that is another difference. Um, I'm not sure nowadays people are really asking them, but once upon a time, this is very famous question, and everybody, at least for the Hadoop developers, they used to ask this question: what is the difference between dump and store? Okay. It may be dependent on code. Yeah, of course, it's how you are writing that one. Okay, like so. I mean, in other words, okay, like here, P, whatever the B variable here, you are storing into the P variable. Okay, like, and then after that, you are using the B variable for the other store statement. That's why it could be able to optimize that, and one job it will try to write into multiple directories like bag output and bag result 2. You could see that both directories okay, like exist here, bag output and bag results 2 as well.
Professor, a small query. When do you prefer a store and when do you prefer a dump in real
If
time?
there is no, if you are not reusing the same variable, okay, like, and if you're using the completely different variable, okay, like, so then maybe it cannot get optimized there, and it may be generated multiple jobs as well. But if it is using the same variable, in case of dumps, it will generate different jobs. Okay. I think if you have to apply complex transformations to get C, we might get different jobs. Uh, here, the point I would like to explain, I would like to stress is instead of store, if you use a dump, it will generate multiple DAGs, irrespective of that one, whether it is a complex or simple or even whether the variable has been used or not, it will generate different DAGs. But in case of store, okay, like it will not generate the different DAGs. And if you are going to use the same variable for the next store statements or the store schemas, whether it's complex or simple, it will not generate different DAGs in case of store. But in case of downs, it would generate different at different jobs, irrespective of that one, whether it is the same or even whether it is simple or complex. Next, uh, let me see that we covered the store versus down. Next thing, um, one of the important things while running your pick script, okay, like so remember always you need to follow this principle: filter early and often. Okay, like so that is one of the key principles. So whenever you load the data, immediately you filter out that. So that is the reason if you closely observe or review any of the fixed rates, most of the filter statements followed by the load. So you want to filter out the data at the early stage itself. So load anyway, load time you cannot help it anything. So while loading, you may have consider all the columns or all the rows here. But whenever you load it immediately, you start filtering. Okay, like so, filter whatever your wear conditions or whatever the filter conditions you first start apply on that. And the next thing, if possible, you try to reduce the number of columns as well. Okay, like that will improve the performance heavily. Okay, like so. Consider only the columns which you require for the next transformations steps or the next step. If you are not going to use all the columns, then please ignore them. Okay, like in the coming stage itself, in the early stages itself. Uh, Also, people would always suggest to write down all the load statements at the beginning of the fixed scripts, and then you start over filtering and uh, filtering of your columns and all that stuff. Okay, like that is also a good idea. And put all your load statements at the beginning. Okay, like and then you start over filtering, and then you start over your join conditions, and then you start over your group and all that kind of stuff. So here I have given you two examples here. So A equal to load my file, okay, like B equal to load other file, and I do have some filter condition C equal to filter A by some T equal to 1, and then I'm join this one, okay, like by uh, I'm, I'm joining C by T and B by X. So I'm joining between my file data and my other file data using the column T and X. Okay. And then after on top of that, I'm applying the group by, and then I am for each E, okay, like I'm using the generate group and then count of $1. $1 anyway, we know that, right? What does it mean by $1? Okay, like so that is the second column from left. We call $1. Okay, and the E. So this is one type of query one. And if you observe the query two, okay, like so where they push the filter at the end. So here the filter condition is at the C level. Okay, like this is where the filter condition has been written. But here in the query two, I have the first A statement load my file, B equal to load my other file, and then followed by the join, and then group, and then for each D, and after that I could apply the filter. Technically, both scripts would give you the same results, but there is a lot of difference between query 1 and query 2. Okay, the query 1 would execute in less time, query 2 will execute more time than the query 1. So this is not a good practice to filter the data at the end. So filter early. This is the key point. So filter early. So whenever you have the load statements, try to filter the data there itself. But both query 1 and query 2 will give the same results. Okay, like from the results perspective, you don't see any difference at all, and you will see the same results in both of them. But query 1 will execute in less time than the query in lesser time. Okay? So this is one of the uh, best practice okay we should follow okay to increase the performance of the script.
Professor.
And the next one, anyway, since I touched the join here, uh, other one join. Um, Try to keep the small file at the leftmost and large file at the rightmost. Okay, like small, medium, large, like that. So you have a small file and you have some large file and you are going to join between the small file and large file. So join, whenever you are doing the join, then keep have more than one source, like small, medium, large, extra large, like that. Okay. Follow this order only. This will improve the performance of your quick script a lot. So if you have like join large first and then small, that also will give you the same result, but that may take a little bit more time than this. Okay. That is about joins, and this one is
Professor.
about like filter early and often. Uh, Third one is project early and often as well. Okay, like project early means like you need to uh, uh, remove the extra columns that you are going to do. Okay, so if your sources or input source has a lot of columns, you could read at the time of load statement. Nothing wrong in that. But whenever after completion of the of the load statement, try to what do you call try to project that whatever the columns that you require for your processing. For example, on the same script, my file, and here I don't require U and V at all because I'm not going to use. If you closely observe, I'm not at all using U and V uh, from the my file. Okay, so but the values it will be carried over until the end. All the mapper users, it will try to write all the columns data from the mapper outputs. So that is the reason like we need to project whatever the columns that have been that only be required. So the columns which never been used, okay, like we simply ignore them. So what we do is like TUV, U might be required because it's a $1 here. That means second column. So V is not V is the one which never been used. Really, like. So we need to filter out the V at all from that. So what you could do is for each A, generate T and U, that will become A1. And similarly from D, this YG, these columns are never been used in the script. So we need to filter out them. We need to filter out the columns and we need to project them. Okay, like that. Then you define the B1 for each B generate only the X, and then you join on A1 and B1 instead of A and B, and then you apply the filter on that and then further group count of data. So this one will give you okay, like this script will run in lesser time than this one. Okay. Anyway, these are all like uh, performance techniques exactly like while writing the script. So just uh, keep in mind okay, like while writing the quick script. The next one is the parallel, using the parallel tag. Okay, like so. Pig allows you to define a parallel tag uh, for any of the join. Wherever there is a group by and join conditions, typically Pig would convert into a reduced cost. Okay, like so for the reducers, um, there is a way how to limit the number of users or how to increase the number of users. So one is that using parallel. You could say default parallel. Okay, like if you set the default parallel as 20, then 20 reducers would be called for your join. I mean, in this script, in the entire this script, maximum it will call only 20 reducers. Okay, like you could limit the number. There is no way to limit the number of mappers in Pig. Okay, like but reducers you could do that now. For each whatever may be the script, and you could also for some of the statements like join or group by, even for that statement you could define some parallel. At the end, you could just add parallel 4, parallel 5, or parallel 20 like that. When you're telling Pig while executing the statement, use that number of reducers. So that is an example. Default parallel, if you use the default parallel, it will be applicable for all the statements in the fixed script. But instead, for some of the statements also, you could use at the end parallel 10, parallel 5, like that. Only for that statement, it uses the number of reducers. Limit.
Hello, Professor.
Sometimes what would happen is we are not at all interested in entire tuples available in that relation. So we would like to know what is the sample, or we would like to know what is the first 100, as well as then a limit is the operator that we could use to limit the
Hello.
number of results. Okay, like so limit is very easy. So here A equal to load my file as
Hello.
UV and B equal to limit A 500. So that means from A, it will get the first top 500. Okay, like any rows beyond the 500, it will simply ignore. But in case of if it has less than 500 rows, it will try to pull all the rows. Okay, that is it. That is the limit operator. Okay. Another one, another performance technique, use distinct or prefer distinct than group by followed by the generate. Okay. There are two ways how to get unique values or distinct values of any column using the tree. So one example, okay, like so here, first I will go through the group by of how to find out the distinct values using group by and generate, and then next we will use the we'll see that how the distinct would be used. A, let's go to the A statement, load my file, and then B, for each A generate B. So here we are interested to see the unique values of the column U. Okay, so that's why in the B we read only the U, and then we are C equal to group B by U. Obviously, since we are looking the unique values of the column U, so that's why we are group by using that column. And then after that, for each C, generate group whatever name is the group. Okay, like as whatever the column name that you want, you could do that one. So I just define it as a unique column name. And then dump B. So this will give you all the unique values of the column U. Okay. Uh, this will run, okay, like this will have no issues at all. You would see the results as expected. But instead of having group and then generate, it's always preferred to use the distinct operator. So in case of distinct, for each for B equal to for each A generate U, and then you just say simply C equal to distinct B. Okay. So instead of writing group by and then like generate all the things, okay, like you just refers to distinct. Distinct will run in less of time than group by and generate. It's very much faster and more efficient than group by and generate. Another performance related stuff. If you're not defined any of the data types in your load statements, okay, like so we would assume if it is a numeric type, okay, like we'll assume the double, and if it is a um, non-numeric ones, it will assume as a okay, like char array. Always define, for example, here on the query one, a equal to load my file as PUV. Here I just define the column names, but not their corresponding data type. So whenever you are doing the mathematical operation on these columns, it would assume that data type is double. Okay, like here for each A, generate P plus U, then here you would see the results in double. I will do. I mean, we could able to run this one. Okay, like I will try to show you the results as well. And the next one, but if you defined as data type T as integer and U as an integer in case of query 2, here you could see the result is an integer. So if you say like dump B, you will see the integer value. But in case of query 1, if you dump B, it will give you the double value. Okay? Let's give it a try. I'm using pick minus x local. We do have a tag data. We could use that example. A equal to load tag data dot text using field 1, field 2, field 3. I have not at all defined any of the data types for the field. Okay. And then b equal to for each a generate, okay, f1 plus f2. Okay, this is what we are looking at. And then dump b. This is a 3.0, 10.0, 15.0. So dot 0 has been added. That means inside it's been treated as double. But the same statement, I will make it as I define the data types as integer, but in the file they are integers. They are not double values. But since you are not defining this data type, it will be considered as a double value. Okay. And then B, so see 3, 10, 15, 13, 15, 4, 9. So since you define the data type, it will be converted as a, it will be treated as a its corresponding type. Okay, like that. So in case of first one, you will see the double value. In case of query 2, you will see the integer value. This is group by and for each and filter. We already covered all the statements here. I do have some other example where you have a stock symbols. Okay, like we would like to know how many symbols are there. Okay, like how many unique symbols. Okay, like exist in a file. So it will just simply count them. Okay, like how many symbols are how many distinct symbols exist. And these are some of the evaluate functions that Pig has already a built-in support. So how to calculate average of the column, a count, we know that what is the purpose of the count, and diff, max, size, sum, bloom, tokenize, concat, count star. Count star will eliminate if any of the rows has null values. So it will give you not null count. Empty, okay, like min, pluck tuple, subtract, back to string. These are all some of the evaluate functions that we could use it in the pig. So if you require any of the other functions, these are only some of the functions. There are lot more. Um, so if you require any of the functionality which is not available in the default functions list, then you would write your custom function. So the for custom to write your custom functions, uh, I think I do have another slide. Okay, like I will explain that one at the time. Similarly, we already saw that big storage, right? To read from text files, to read and also to store the text files from the fixed script, you could use the fixed storage class. Similarly, there is a binary storage, there is a JSON storage, JSON loader and JSON storage. A big dump is also there. Okay, like ORC storage, HBase storage, Avro storage, accumular storage. Again, it's not limited to only already available storages. You could also write your own storage UDF. Okay? By writing the UDF, you could write the UDF in Java or Ruby or in Python. You could choose any of the language to write that. This is about load and store functions. Um, I mean, my point is, I don't want to. I want to highlight that just these are the store functions are already available in the tool. That is only the purpose here. And some of the tuple level functions, okay, like are conversion from tuple to bag and bag to some what do you call it, complex data type like math. So two tuple, some of the expression types, okay, like you could convert into a tuple. Two bag converts are more expression to type bag. Sometimes we may require to convert from bag to tuple or tuple to bag or whatever the operation that we are doing inside of that. To map. So this will convert the set of key value pairs into the map type. Top. Top is if you want to return the top results, top two or top three or top n tuples in the bag of tuples, it will be the top. So these are the tuple level functions. And datetime functions, add duration, years between, weeks between, get year, get month, get week, years between, months between, days between, so that you could pass the two dates. Okay, like it will give you how many number of years between uh, date one and date two. Okay. Similarly, if you try to call the weeks between, it will give you how many weeks are there exist from the date one to the date two. Get year, typically you pass a complete timestamp or date time, and it will fetch the year from the date you provided. Get month will be the month. Get week will be the exactly which week starting from the beginning of the year. Get day will give the run, get hour and get minute, get second and get millisecond. Okay, like it's very um, self-explanatory. The purpose of these functions. Subtract duration. Okay, like so you have the date one and you subtract from there like 20 minutes or like 4 hours, then it will give you the date afterwards. To date, okay, if you want to convert from any of the uh, date in string format, okay, to the date, you could give the to date. To string, if you want to convert from date to particular format of the string, you could use the to string. To Unix time, this is something like epoch time. It will give you a long numeric number starting from, it will calculate that, okay, starting from the 1970, I guess, 1970 and 1973 year, okay, like it will give you that time difference. 2 milliseconds, it will convert into a milliseconds, okay, like, and you could also write your own custom date function, a custom data function. Math functions, okay, like starting with absolute value, okay, like sine value, cos value, tan value, exponential value, random, round, okay, it will round to um, a, what do you call it, 2 digits, round to 2 digits, round to 1 digit, round to 3 digits, like that. You could specify that one. And round 10, it always give the 10. A logarithmic value, lock and value, seal, okay, like all the mathematical functions are very similar to any other programming language or any other. And conceptually, they are all similar to any other domain or any other language. Seal, okay, like which will give you the uh, nearest lower number, and floor, floor will give you the nearest to lower number, and seal will give you the nearest higher number. Quadrat, cubit. So, of course, you could write your own custom function as well. There are string functions, ends with unique ID, starts with string split, print, regular expression, um, LC first. So these are all some of the index functions which are again available. If you encountered a situation where you need a function which is not available in the list or in the default list, you will end up writing your own custom function. Okay. I just told you Java, Ruby, Python, but Pig also supports Jython, JavaScript, Groovy, Python. Okay. So you could write UDFs in all these languages. But most of the people write Java only because um, the, one of the expectations from the Java developer is, I mean, from the Hadoop developer is also having a little bit knowledge on Java. So that is the reason most people would choose Java to write their UDFs. I saw some of the UDFs written in the Ruby and Python, but I never saw any UDFs in Jython, JavaScript, and Ruby. But it has um, a capability which would allow you to write UDFs in this language. Okay. Um, One interesting concept around Pig is called like a piggy bank. Um, it's a repository of all customized functions written by the people across the world. Um, First of all, if you want to contribute anything, any new function to the pig, first it will be there in the piggy bank. Okay, like so, and then people would be using that, and it's been value added and it's been reliable. Then they move from piggy bank to the default list. Okay, like from version to version, like that. Um, so it has all the load store functions, data functions, string functions, evaluate functions, mathematical functions, statistics functions, like that. There are a lot of functions available in the piggy bank. So whenever you found out that there is a need for new function, first verify that some people have written any function in the piggy bank. Okay. Since this is related to the pig and it will call repository is called as a bank, so they use this word, and it was very much appropriate for the like to uh, find that word. So it's called just piggy bank, and where it will be available in the piggy bank, it will be wherever your pig is got installed. So there itself you could see that piggy bank folder, and inside that you could see all other functions. I will show you as well. Okay, like where is this piggy bank. And the next one, data flow. Uh, this library has been built by the LinkedIn people, the people who are working in the LinkedIn. So they contributed, okay, like towards this um, third party library. Okay, like this will come as a jar. So data flow jar, and then like it will be you just copy over into your library path, and data flow they have built a very nice what do you call UDFs um, to convert into a bag, to convert into a tuple, back to tuple, tuple to bag, intersection of one relation to another relation, one relation minus another relation, and also like statistics functions, like how to compute the variance, and uh, many of the functions on the bag, okay, like they already has that. So if you ever got any situation where you end up writing a customized function, first thing is you need to verify that in piggy bank. Second one is verify that whether the data flow has anything related to that. And if so, you just try to get that done. And also it has a lot of utility functions. I don't, due to this space available here, I've not listed all the functions, but there are a lot. There are more than 100 or 150 functions available in the data flow. Page ranking functions, okay, like random numbers, assertions, MD5 related, and there are a lot of map related, okay, like longitude and latitude based. It will find out that like distance between one landlord pair to the another landlord pair, and also like it will find out that how many common points are there between one geographical area to another geographical area, like that. Lot of lot of functions, okay, like um, so these are the two standard repositories or something like that. Like so, people would be um, heavily using, and from the pig developer, okay, like so, any interviewer they would expect that having knowledge on this, what is a piggy bank and what kind of things are available in the piggy bank, and how to see that piggy bank function. And the next one is what is data foo. Okay, like what are the how to use the data foo related functions in your pig code. Also, people would ask that one, did you ever use data foo? In which scenario that you have used data foo? Why did you use data foo? Like that. Data foo is very famous in the pig world. Whenever you write some pig script, there is a, or not the pig script exactly, like whenever you upgrade the pig from one version to another version, okay, like so, people try to benchmark the uh, pig by running some of the set of the queries. So for benchmarking, okay, like there is a framework or there is a set of scripts that people would be using. It's called like pig mix 2. There is a pig mix 1, pig mix 2. Pig mix 2 is the latest one, and it has 17 queries related to the benchmarks. Okay, like so, um, they have been contributed to the big community. Okay, like so, you could just run all these queries, and then you could store how much values. I mean, sorry, how much time that it has been taken by this queries. So whenever you upgrade peak to the newer version, and then you run again this benchmark queries, and then you could see that whether it's been improved or whether it is there. So this is just for benchmarking. Uh, Once you write the pig script, okay, like there are some frameworks available to run unit tests using them. Okay, like so, Pig Unit is one of the framework. Okay, like so, it will um, any it will look like any other JUnit frameworks. Okay, like it's very easy. Okay, like so, you could use the unit testing, regression testing, and rapid prototyping. But unfortunately, if you want to use the Pig Unit, you need to write a Java code. Okay, like so, writing a Pig script is easy, but writing it unit test cases for big script that you are written in Java that required again with Java skills and all that stuff. Not many people are inclined towards using the big unit, but some organization has. So there is a way exactly like to automate or to test all your big scripts using unit to define the unit test cases for your big scripts. But mm, it's very cumbersome. Okay, like it's very long script that you need to write that big. To a pig will be like 4 lines, or suppose you have written the 4 lines of pig script, but to write unit test cases you will end up writing 200 lines of 200 lines to test that 4 lines. So many managers or many people they don't like that one, um, but framework exists. Okay, like so some people that's why many people they don't prefer to use pig unit. But other than pig unit, there is no way that you could run your unit testing, or else you need to run like down or describe, illustrate, okay, for every statement that you are written, and then like so only the developer will can that. But there is no way that like to prove whether he has been written correct or not. Like uh, I do have 5 more minutes. Okay, like so. Any questions? I will take any questions from you, and maybe probably next class I will show you how to write or how to uh, write a big script to get our word counts. Okay, like so, any file which has any text, any file which has a data in text format, how to write word count, counting the word and then its corresponding frequencies using the fixed rate. I will show you in the next class. Any questions?
Professor, hello, Professor. Hello, 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 Professor.